Hey everybody! The purpose of this video is to get you guys some solutions to the Outliers quiz. Just a bunch of values. I can't remember where I pulled these values from, honestly. They did come from a source somewhere, which I have completely lost. But it doesn't matter. The quiz is mechanical, so the point is to get some mechanics. So here they are. I want you to draw a histogram of the data to kind of get an idea of shape. So far, we've learned two different methods for finding outliers. We'll do one of those. Then justify the choice of method. Okay, so it says to use your TI only because this is going to be easier since I'm using a PC. I want to use Excel instead, which doesn't really change anything. Text to columns, delimited, next, space, finish. Okay, there's my data. Let's make it all the same size so it's not so much of a headache to look at. Apologize, just be patient with me here, friends. Let me just get through this. Calibri maybe, so it all looks the same. All right, let's see. The lowest is 30, the highest is 1441. I'll bin it by 100. Here we go. 300, 400, 1441, so the highest I have to go is 14, actually. What I'm doing here real quick is I'm setting up a frequency distribution using the frequency command in Excel. If anybody ever wants to know how to do this, I taught my 105s how to do it in the last project. I never taught the 243 folks how to do it, only because we don't have access to Excel in class very often. But once you have this Excel, this little bit of Excel under your belt, it's kind of a nice way of actually dealing with data. And so I'm going kind of quickly through it as I'm talking. Let's see, 115. Yeah, I want to talk about this momentarily. So what I'm going to do is I'm going to insert. Excel calls it a column chart. So we'll just do that. Beautiful. It looks a little goofy because you have to delete that column right there, and there it is. We're going to mess with it a little bit. There we go. Let's see. We'll make a no gap. We'll do a border color of black with a style a little bit thicker. That's nice, good. Looks like we might have an outlier right here, at least, if not more. Okay, so far so good. I do want to change these labels. Let's select the data and make the horizontal axis label that instead. Beautiful. So just real quick, what you're looking at, when this says 100, that means between 0 and 100, between 100 and 200, between 200 and 300, 300 and 400, up to between 1400 and 1500. Obviously, if we had more time and if we wanted to, we could make this more, I could change this to, instead of just being 100, I could make it 0 to 100, and then that would update it on the histogram over here. So if you wanted more time, you could do that. But the main reason I had you do the histogram, and your TI histogram will look similar to this. It might not look exactly the same. If you use different widths of your bars, it's going to look differently. But the main reason was to see, is it roughly bell-shaped or not? And I would call that roughly bell-shaped. There's a really neat little command called skew that you can totally use, equals skew. And then you got the data set. And that is not far enough away from 0 as to arouse suspicion. If you don't remember how to measure skew and you want to, for some reason, you can go back and look at the homework on variability, in which we learned something called the Pearson second skew coefficient. So regardless, it's not skewed enough for me to think that I can't trust the average standard deviation. So I am going to spell that correctly. And then I'm going to calculate the sample average and the sample standard deviation. So equals average of these values, boom, and then equals the standard deviation of these values. I'm just simply using those numbers that we learned about in your first exam. So the mean and the standard deviation, there you go right there. Okay, so now we've got that, and since I think those are trustworthy values, I'm going to use those to set up two standard deviations, because I think that's the method I want to use. So here we go. 2 standard deviations. The low point is going to be the mean minus 2 times that. So anything below 100.9 is going to be counted as a standard, as an outlier, based off of 2 standard deviations. And that tells us that the 30 is an outlier using this this calculation. I'm going to put low here and then high here, and this is going to be the mean plus 2 standard deviations. So this tells us anything over 1051 would be considered an outlier. So looking back at the raw data, that would be either of these two. So if you use the 2 standard deviation method, you're going to have 3 outliers: 30, 1068, and 1441. So that would be using the 2 standard deviation method. The justification for using it would be that the data is roughly bell-shaped, and that's totally legit. So that's one answer for you. If you chose to use the other one, you'd have to calculate the quartiles, and there are commands for the quartiles. If we take the quartile, that first quartile would be 436.3, the 25th percentile. The third quartile, or the 75th percentile, is going to be 738.5. So here's Q1, Q3. The interquartile range is going to be the difference of those two, blah minus blah. So 50% of the data is 302 or fewer points away from each other. To set up the low and high using the interquartile range, we'd have to do, for the low, would be Q1 minus 1.5 times the IQR. So anything below negative 17. Well, clearly there is nothing that's negative, so there are no low outliers. The high would be Q3 plus 1.5 times the IQR, and that's anything above 1192. So if you use the interquartile range method, that's the only outlier using the interquartile range method. So depending on what you did, you're either going to have 3 outliers by definition, or you're going to have 1 outlier by definition. So 1441 is definitely an outlier. 1068 might be, depending on how you measure outliers, and 30 might be, depending on how you measure outliers. 1441 definitely is. So there's some solutions for the outliers quiz for you. Hope they were helpful, and we'll catch you in class.